Let's switch gears and talk of electric vehicles. Uh, Electric vehicle is today a very sophisticated electronic system on wheels. Where is India on the electronics and the electrical engineering aspects of EVs?
Actually, even an ICE vehicle, even an internal combustion engine vehicle today is sophisticated electronics.
Sure.
Okay. I mean, the only major difference between the two is that in the ICE vehicle of today, the mechanical, electromechanical, or mechanical, propulsion system is controlled by very sophisticated electronics. Whereas the electrical propulsion system is controlled by very sophisticated electronics in the case of electric vehicle. Otherwise, the rest of the electronics is as sophisticated now in the two. Okay. So I would say broadly, electronics and intelligent software-driven electronics is entering everything, right? From washing machines to cars to everything, and therefore all these systems have higher part of their values now in the electronics and in the software and in the AI that's used in those machines increasingly. That is one phenomenon that's happening, whether it's ICE, ADAS 2,
Sure.
is just electronics and in software, sensors, and so on. The electric vehicle has another aspect to it, and that is the other part of electrical engineering, which was probably dominant before the electronics revolution, and that is the electromechanical part of it, the energy transfer,
Machines.
machines. When I joined as a student in the electrical engineering department in IIT Madras, it was the machine section that was larger and which had many of the stalwarts of the department. Then during my career as a faculty member here, that declined because nobody would go into that and so on. Of course, I had a half suspicion even in those days that it'll bounce back, and that's what happened with the return of electric propulsion in vehicles and everything. Now it'll come to planes and everything. So it's come back. But the point is, machines which are actually deal with the conversion of electrical to mechanical and vice versa energy have always been important because that is the heart of the electrical power system that drives our lives, and now of all the propulsion systems. So this area, which had seen a sort of a decline, is now back with full force. And obviously people have taken time to figure out that this is now a very important area, and students are not yet flocking back to the extent they should. Many institutions are bereft of faculty in those areas. They have to build them back. So that's a problem. But the real challenge there is, compared to the machines that were there in the 50s and 60s, which drive all our power stations and everything, and our motors. The thing is, if you look at electronics today, if you look at phones today and so on and marvel at them, those machines are marvels. I mean, apart from the human body, which works for 80, 70, 80 years without too much of a problem, the only other machine that I know that works without any problem is the electric fan. And except for
And it's the
cleaning,
ball bearing that could go bad,
yeah,
not the.
even that, they've mastered it. I mean, I've never seen, no homeowner has problem with his fans.
Correct.
They have problems with everything else.
Correct.
They don't have. So the electrical machine, the synchronous machine, these are all they run on alternating energy. They AC current. It's a marvel of engineering. Rely from reliability, and it just runs. It's very simple in its construction. The From that high point, and everything was built on that. Now there is a complete revisit, because what has happened is, this has become, if you are going to use if you're going to use electrical propulsion rather than mechanical propulsion, if you're going to use motors in cars and so on, you want to build them now as well as you can. And unlike a fan, which sort of has to work at pretty much at one speed, you can change speeds, but it's not changing all the time. There's no requirement that it should also produce torque. Now you're trying to, when you're doing for propulsion, you have multiple requirements which are against each other in terms of what you need to do, and you want to do it well, and you want to do it efficiently, and so on. And so I think all of these designs are being revisited using all the new tools that are available, computational tools for design, much more precision. So all these have to do with the strength of the magnetic field, have to do with rare earths, have to do with the gap. how minimally you can make it. So it's become a very multidisciplinary area where I think people who have a good understanding of the state of the art in bearings, in control, in design, in numerical electromagnetics, everything will come together. And the thing is to when these machines want to do different things, go from high torque to high power mode in a jiffy, it's electrical machine. So somewhere the electrical signal also has to go from one end to the one type of signal to another. So the electronics that can also withstand these quick changes also that's called power electronics.
Yes.
That is also new. That's very different from the low power electronics that goes into smartphones and stuff.